Hi students, now we have done yesterday the basic proportionality theorem and the converse of basic proportionality theorem. Okay. Now today we are going to see some application of basic proportionality theorem that comes. We got a new property coming up over there, and what is the name of the property? Is property of an angle bisector of a triangle. What is that over there? Property of an angle bisector of a triangle. Let's read out what is that property of an angle bisector of a triangle. The bisector of an angle of a triangle divides the opposite side to the angle in the ratio of the remaining side. I'll read again one more time. The bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining side. I'll explain you now with the diagram. What is that there? Suppose the bisector of an angle of a triangle. So that means I must have a triangle over here, triangle A, B, C, and there is a bisector of an angle of a triangle. Now can I take this over here? In this case, AD as a bisector of an angle. You know what is a bisector? Which cuts the angle into two equal parts. So bisector of an angle of a triangle divides the opposite side opposite to angle. Now this is your angle, which is the bisector of this angle. Divide the side opposite to that angle, which is the side opposite to it over here is BC, and it's divide the BC into two opposite angle in the ratio. In the ratio, that means what can I have over here? So I'll be having here in this case is BD upon DC divides divide the side opposite to the angle in the ratio of their remaining side. Remaining side is what is nothing but here I have a BD into DC will be equal to AB, the remaining side. AB and AC are the remaining side. So you will be getting over here in this case BD upon DC is equals to AB upon AC. This is what is being told over here, that the bisector of an angle of a triangle. This is the bisector of an angle of a triangle. Divides the opposite side opposite to the angle. Divides the side opposite to the angle. This angle is there, and to this angle there the opposite side is BC, and it divides in the ratio of the remaining side. That means BD upon DC is being cut by the bisector, and these AB and AC are the ratios. That means this is the property is being called as here of angle bisector of a triangle. Angle bisector of a triangle. It's like that. If I want to write it over here, it's something. If I'll be writing in triangle ABC, ray AD is the bisector of angle A. Is the bisector of angle A. Therefore, you will be getting what over here in this case BD upon DC is equals to AB upon AC. This is how you will be getting over there. That is called as the property of an angle bisector of a triangle. Now next one is the converse of angle bisector triangle. Converse means it's everything will go ulta. We have to, this is the thing. What ulta means what? What was given first? You have a ray AD is the bisector of angle A. Okay, bisector of angle A, and therefore the ratios are equal. In this converse, what will be coming over there? If the ratios are equal, then what you'll be getting over here in this case, therefore the ray AD is the bisector. Ray AD is the bisector of angle A. It's the same thing. If you prove these ratios are equal, then it is a bisector. AD is the bisector. Okay, here angle AD is a bisector, therefore the ratios are equal. And here in converse says that if the ratios are equal, then the ray is a bisector of that angle. Okay, so that is what the property we have studied about, the property of an angle bisector of a triangle. Now let's start with the property which we have done. That the angle bisector of a triangle property. On that related in that property we are going to do the related to that we are going to do the sums. Now practice set 1.2 we are going to do third sum and sixth sum. Both are related to the same property. First I will do the question number third. Now it's very simple. Look at the in triangle M and B. NQ is the bisector. They have given that NQ is the bisector of angle N. Can you see that? Then Mn they have given 5, Pn they have given 7, Mq they have given it what over here 2.5. Find QP. QP they told to find. It's very simple and very easy. So what you have to do to here is, I told you that over there, you have to write it over here first in triangle M and P. Yeah, and then you have to write a statement over there that this seg NQ, you have a seg NQ is the bisector of angle N. Yes, NQ is the bisector of angle N. Therefore, can I apply by the property of angle bisector of a triangle, angle bisector of a triangle. Now what is the property? I told you last time also. This is nothing but I will be having over here, in this case, you know that MQ, you will be having over here MQ upon QP. MQ upon QP will be equal to MN. Can I have over here MN, the two sides, upon NP. Can I have over here NP? MQ upon QP is equals to MN upon NP. I got it over there. Now what I'll try to do to here is I'll try to substitute the values. Now when I try to substitute the values, I'll be getting the answer this over here is nothing but MQ ka value is what? 5. QP ka value we have to find out. Okay, so that will be written as QP. Okay, this QP we are told to find out in this question over there. Yeah, and then MN ka value we got it what? 5, and NP ka value we got it this is over there. MQ ka value I got 2.5, sorry, 2.5. QP ka value we have got to find, MN ka value we got it 5, and NP ka value we got it what? 7. It's so simple, very simple. Now what you have to do is nothing but you have to cross multiply. QP will go and multiply with 5. So I'll be having over here QP is into 5 is equals to 2.5 into 7. So you'll be getting what? 2.5 into 7. And now what I have to do to here, I have to write QP over here 2.5 into 7 upon 5. Upon 5. So I'll be having over here in this case 2.5 upon 7. Now here if you check this out carefully, that so easily you can cancel this out over there. This 5 came and divided because it is multiplying with QP, so it will come and divide. 5 on the 5, 5 are 25, but it will be 0.5, 0.5. Now what is to be under 0.5 you have to multiply by 7. So in this case you will be getting QP is equal to 3.5. You will be getting the QP value 3.5. And therefore, what you have to write the answer is the final answer. You have to write it over here. QP is equals to 3.5 units. You got that over there? So this is how we finish the so simple sum. Your question number 3 is got over. Now let's go to the same thing for the question number 6 also. Now question number 6 again, they have told that over there. In this case is cube using this. Find QP using the information in the figure. So from the information you can make it out here again. You have NQ is the bisector. You have here NQ is the bisector. Again I'll be writing over there in triangle M and P. In triangle M and P. Seg NQ is the bisector. NQ is the bisector of angle N. Therefore, by the property of an angle bisector of a triangle, angle bisector of a triangle, angle bisector of a triangle. Now we got it over there. Now same thing I'll be writing what? MQ. Can I write over here? Same MQ upon QP is equals to same what we did here also. MQ upon QP is equals to what will come over here? First MN. What will come over there? MN upon NP, and then upon NP, and then same thing we have to substitute the value. MQ ka value we know it was 14. QP ka value we are told to find. See here QP ka value they are told to find again here. Okay, MN ka value is what? 25, and NP ka value is what? Oh yeah, you check this out in the diagram. NP ka value is what? 40. So again you have to cross multiply. So when you cross multiply over here, you will be getting is nothing but this is QP, and therefore it will be QP into 25, QP into 25 is equals to, QP into 25 is equals to 14 into 40 is equal to 14 into 40. So therefore you will be getting QP is equals to 14 into 40 upon 25, upon 25. 5 5 are 25, see 25 will come and divide, so you will be having here 5 5 are 25, 5 8 are 40. 5 8 are 40. Further cancellation is possible, it is not possible. 5 and 8 will not go, and this 14 and 5 will also not go. So what we have to do here is nothing but we will multiply 14 into 8. 8 for the 32, 2 here 3, carry 8 1 the 8 and 10, 9, 10, 11. So you will be getting 100. QP is equals to, here in this case you will be getting 112 upon 5. So what you have to do there is nothing but 112 you have to divide by 5. 5 2s are 10, and you will be getting what, 1 minus 0 is 1, 0, and this is 12. 5 2s are 10, again you will be getting 10, and you will be getting 2, and you have to put a decimal, and 0. 5 4s are 20. So you are getting the answer is nothing but QP ka value you are getting it over here is 22.4, and this is your final answer for this question. And they told to find the value of QP, and we got the value of QP. Okay, that's how we finish the question number 6. Okay students, now let's go for your exercise number practice set 1.2 ka question number 9. Now question number 9, again the same thing, same sum. You have a triangle ABC. Check it out, the triangle ABC. You have saying BD is the bisector of angle ABC. Can you see this? BD is the bisector of angle ABC. AB ka value they have given it what? X. BC ka value they have given it what? X plus 5. AD ka value is X minus 2. And BC ka value is X plus 2. Okay. Now what we have to do here is nothing but they told to find the value of X. Okay. Do you have to get that these values have been given in terms of X, so the X variable, you have to get the value of X or the thing. It's very simple. What we have done the first two sums, so they same that way only you have to do it here. What you are going to do here is nothing but we are going to apply the property of angle bisector of a triangle. First same thing will be writing over there in triangle ABC. You have said BD is the bisector of angle ABC. Okay, and then same thing, therefore by the property of an angle bisector of a triangle, by the property of an angle bisector of a triangle, I have to apply the property. It's the same thing. First what we'll be writing over there, therefore you will be getting what, AD upon DC is equals to what will come over there? AB upon BC. AD upon DC is equals to AB upon BC. Can you saw that carefully? Yeah. And now what I am going to do here is I am going to substitute the value of this over there. What is the value of AD? AD ka value is what we have over here is X minus 2 upon DC ka value we got it over here X plus 2. X minus 2 upon X plus 2 is equals to AB ka value is what? X. And you have over here BC ka value is what? X plus 5. X plus 5. Is that correct? You have AD ka value, can you see in that over there? X minus 2. DC ka value is over here X plus 2 is equals to AB ka value is X. BC ka value is what? X plus 5. Now what has to be done? It's nothing but very simple. You just have to cross multiply. So when you cross multiply, what will happen? This X minus 2 will go and multiply with X plus 5. And X will go and multiply with X plus 5, X plus 2. Now here when you multiply, see this, X minus 2 will go and multiply with X plus 5 and X will go and multiply with X plus 2. Now here we have to multiply these two brackets. It's same like here now. You got an algebra coming up. We have done the 9th standard also. This first X will go and multiply with what? X plus 5. And this minus 2 will go and multiply with X plus 5. You have this X will go and multiply with X plus 5. And minus 2 will go and multiply with X plus 5. Is equals to, I will keeping this here X into X plus 2, I will keep as it is. Now therefore, now what will happen over here? This x will go and multiply with this x, and this x will go and multiply with 5. X into x is what? X square plus 5x. Then this minus 2 will go and multiply with x, and this minus 2 again, it will go and multiply with 5. So this will be minus 2 into x is minus 2x, but this minus into plus will become minus, and 2 5s are 10 is equals to, you got it over there? How I can multiply it over here? X into x square, x into 5 5x, minus 2 into x is minus 2x, minus into plus is minus, 2 5s are 10. Now here you will be getting here again this x will go and multiply with this x, and this x will go and multiply with 2. This is very simple. X square plus 2x, x square plus 2x. Now I'll show you something over there. What we have to do it here, this x square from the left hand side and this x square on the right hand side, which are having same sign, can be cancelled. Instead of taking left to right, right to left. Okay, so and you can see these are 5x minus 2x is a like term, so they can get subtracted, so you will be getting what over here is 3x. 5 minus 2 is 3, minus 10 is equals to 2x. 10 doesn't have any x, so they are not a like term. Okay. Now what will happen over there? Again, this like term has to be get from the right to left. You can see that 2x and 3x is a like term, but it is on the right hand side. So what I will do, 2x will come to the left, minus 10 will go to the right. So this will be what? 3x minus 2x is equals to minus 10, it will become plus 10. So 3x minus 2x is what you will be getting x, and this is what 10. So you got the value of x is 10. So what they have told to find the, they have told to find the value of x. We got the value of x is nothing but 10. So therefore you have to write that answer is x is equals to 10, and this is what you have to write there. They told to find the value of x. Okay, fine. So this is what we finished with the sum. Okay students, now we are going to go for the question number 1 of practice set 1.2. This is all related to your converse of angle bisector of a triangle. Converse of angle bisector of triangle. Now you can see that given below the some triangles are there in that question number 1 and question number 2, and the length of the line segment is given over there. The identify in which figure the ray PM is a bisector of angle QPR. Now what you have to do to here in the first sums, they were given that it was a bisector, and you have to get the ratio and get the answer. But now here they told that it is a bisector or no, you have to prove it over there. So what we have to do it over here is nothing but simple part over here. I'll be writing here in triangle PQR. You have a triangle PQR. Can I have the ratios coming up? Here in this case, QP. I'll be QM upon MR. QM upon MR. Now what is the QM upon MR is nothing but you have the value of QM is what 3.5 and MR ka value is what over here 1.5. So can I have over here 35 into 10 upon 15 into 10. What I did over there, I removed the decimal, and this the decimal of this over there, and this 10 will get cancelled. Decimal of the denominator will go up, and decimal of the numerator will come down. Nothing there. And this 5 3 the 15 and 5 7 the 35. So I'm getting what 7 upon 3. That's my statement number 1. Then you know QM upon MR. Then we're going to check it out. PQ. What is that over there? PQ. You will be getting over here is nothing but PQ upon this is over there. In this case over there PQ. You will be having over here PQ upon PR. PQ upon PR. Now PQ upon PR is equals to, you will be getting over here 7. Now PQ ka value you have over here in this case is 7. Now 7 over here 7 upon 3. So this is what you got a statement number 2nd. Now you got a statement number 2nd. Now you can see these ratios. QM upon MR is equal to 7 upon 3. PQ upon PR is also equal to 7 upon 3. So from both the things you came to know that the QM upon MR is equal to PQ upon PR. Can you see that the ratios are equal, and from where I got it over here? From first and second statement. I got a value from first and second statement. After getting the first and second statements, if the ratios are equal, then we can say that P ray PM. Therefore, ray, can I say that ray PM is the bisector of angle QPR, and you have to write in the reason by converse of angle bisector of a triangle, by converse of angle bisector of a triangle. So can you see this over there? Here in this case the ratios we prove equal. If the ratios are equal, then the PM is a bisector. So here in this case we got PM as a bisector of the triangle. Same thing we have to check in this also. So again I'll be going in triangle PQR. Can I go in triangle PQR? In triangle, same thing in triangle PQR. Again I'll be checking the ratios. Here in this case QM upon MR. QM upon MR. What is the value of QM upon MR? 6 upon 8. 6 upon 8. 2 3s are 6. 2 4s are 8. So I got what? 3 upon 4. This is what? Statement number 1. Now I got QM upon MR is what? 3 upon 4. Now I check the ratio of PQ. Can you see that? PQ upon PR. Check this out from where the starting there today. PQ upon PR is equals to, you'll be getting over here 7 upon 10. PQ is what? 7 and PR is 10. So 7 and 10 is cancellation possible? No, it is not possible over here. So it will remain as it is. And from this we came to know that QM upon MR का value is 3 upon 4 and PQ upon PR का value is 7 upon 10. Are they equal? No. So they are not equal. PQ upon PR are not equal. So QM upon MR is not equal to the ratio of PQ upon PR. Therefore, you have to write it over here. The statement coming up. Therefore, you have to write therefore PM is not the bisector. PM is not the bisector of angle QPR. So if you check this out, the question number 1, in that the ratio was coming equal, therefore then it is a bisector. 7 upon 3, 7 upon 3. Therefore PM is a bisector. But if you check in the question number 2, QM upon MR is 3 by 4, PQ upon QR is also 7 by 10. So the ratio is not coming equal. If the ratios are not equal, then ray PM is not the bisector. Okay. So this is about the converse of angle bisector of a triangle. Okay. Yes, students. Now we are going to study another property which is called as property of a 3 parallel lines and their transversal. What we have studied last time is the property of an angle bisector of a triangle. Now we are going to study called as the property of a 3 parallel lines and their transversal. Let's read out that this way. The ratio of the intercept made on a transversal by 3 parallel lines. I'll explain you all that today. The ratio of the intercept made by the transversal by 3 parallel lines is equal to the ratio of the corresponding intercept made on any other transversal by the same parallel line. For example, I'll show you this today. I have a 3 parallel lines over here. Can I have a 3 parallel lines over there? So this is your line L, line M, line N. Okay. Now what they are telling you here, the ratio of the intercept made by on a transversal by 3 parallel lines. So I have a transversal. Can I have here? This is called as transversal, and this is your name of a transversal is P, and it is making a intercept. That is your here. This is called as intercept. A, B, and C. These are called as intercept. Everybody knows this. Okay. This is called as transversal. Line P is called as a transversal, and they are making an intercept on 3 parallel lines A, B, and C. Intercept at A, B, and C. This is called intercept. That is the ratio. They are telling the ratio of the intercept made on a transversal by 3 parallel lines. So what is the ratio in this case? Is what here is AB upon BC. AB upon BC is equal to the ratio of the corresponding intercept made on by any other transversal or by the same parallel line. That means if I have any other transversal, if I have on the other transversal on that same parallel lines, can you see that? Equal to the ratio of the corresponding intercept made by any other transversal. That is what any other transversal by the same parallel line. So you have a same parallel line, and I have a Q as another transversal, and I can have over here, in this case over here, E, F. Can I have over here M and P? Can I have over here M and O? I can write it over M and O anytime. This is your transversal Q, and it is making an intercept M, N and O, M and O. So that means that the ratio of the first transversal curve will be equal to the ratio of the second transversal curve. That is your Mn upon No. Can you see that? If you have three parallel lines and transversals are there, then the ratio of the intercept made by that transversal is equal to the ratio of the intercept made by any other transversal will be equal. Can you see that? Okay, so AB upon BC will be equal to Mn upon No. Understood? And this is called as the property of three parallel lines and their transversal. Yes students, I have, while doing this practice set 1.2, I have not done this two sums over there. I want you to try. Now you try for your homework over there. That is your practice set 1.2 the first question, the third sum. It seems similar sum what I have done it over there. It's same sum, you try it on your own. And the sum number 8. Sum number 8 is of the property of an angle bisector made of angle bisector property, and then first the third question is the converse of angle bisector property. So I want you to do at home all this over there. So just I will be going a brief whatever I taught you all over there. In practice test 1.1 we have done the property, that is the ratio of the area of the two triangles is equal to the ratio of the product of the base and corresponding height. And then we did that if the height is equal then the ratio is equal to corresponding bases, and if the base is equal then the ratio is equal to corresponding heights, and if the base and height both are equal then the ratio is equal to 1. We have done in the practice set 1.1. And in practice set 1.2 up till now we have done with the basic proportional theorem and the converse of basic proportional theorem. Then we did what over here is angle bisector of a triangle and the converse of angle bisector of a triangle, and I have thought one more, that is the intercept made by three parallel line and the transversal. These are the all properties and theorems we have done it up till now. This in exercise number practice set number 1.1 and 1.2. Okay.